Okay, so today we need to start off with your network externalities. Okay, now network externalities in itself means that there is, just a second. Yeah, so means your demand is affected by an external force. Okay, now the first example of a network externality is the bandwagon effect. Now, bandwagon effect is the word you need to remember in this bandwagon effect is the word fashion. So, if a product is in fashion, right? So, it will be demanded more at a price. So, if a price is set, right, it will be demanded more at that price. And as a result, the market demand curve, this is the market demand curve, it will become flatter, right? Simply because people think that everybody is buying it, so let me also buy it. Now, let me just give you the example of COVID-19, right? So, during that period of time, everybody was buying oximeters, right? Just to measure the oxygen. Everybody was buying a specific medicine of Dolo. It was because that came into, in the market like a trend, because it seemed that this is a necessity that everybody should have, right? And that is why at the same price, the market demand increased considerably for it, right? So this is what bandwagon effect is, that seeing others, you purchase that commodity, right? So that is the thing. Now, the bandwagon effect is an example of a positive network externality. Because you see that, okay, you are lured to buy more just seeing the trend of the market, right? If one thing starts happening, then people think that this is very much important. For example, like if we see that smartphones, when they came into the market, right? After a certain point of time, everybody started believing that yes, you need to have a smartphone, right? So everybody started buying that, okay, irrespective of the price, but only because all of your friends had, your social circle had it, and so on. So that was like a positive network externality. Okay, everybody started, there was a trend of smart watches, right? Companies like Fitbit, they grew, exponentially, simply because a trend came into a market and everybody started having a smartwatch. Okay, so it is a kind of a positive network externality, right? And it is mostly because of the demonstration effect, that you feel that it is important, right? It is important to own that particular good. It is important for it. But the complete opposite of it is the snob effect. And snob effect is that if you think that everybody is buying that commodity, then you will not go for it. So as a result, the demand decreases. If everybody starts going for that, you will not demand that good. So, for example, let's just take the example of travel influencers, right? Now, what happens in their cases, they will not go to a, like a popular spot or something. They will find unique locations, right? So their demand for popular locations is decreasing simply because others are consuming the same thing. So what will be their job? When everybody is going to see the Taj Mahal, they will not invest their time on Taj Mahal, right? So their demand would fall. So that is what your snob effect is, right? It's mostly in the case of, say, antiques or, prestigious goods, right? So, for example, in case of diamonds also, right? If everybody, there was a trend, firstly, there was a trend of silver jewelry, right? When everybody started having it, then there came a trend of gold jewelry, that, okay, the rich or the ultra rich, they started consuming gold, right? Simply because everybody had silver, right? So then gold became their go-to place. But then slowly and gradually, people started consuming gold as well, Then they shifted their demand to diamonds, right? Which a normal person could not afford them, right? So diamonds was their thing. It stood them out from the crowd, right? It made them more appealing. That's why they demanded for diamond despite a very high price for it, right? And then people started owning diamonds also. These days, every person can afford one or the other diamond, right? So be it a lab grown or be it a mine, right? So then they jumped onto platinum jewelry, right? Which again took them apart from the crowd. So this is what the effect of snob effect is, right? So higher the price, more appealing it is for them. But if everybody is consuming that commodity, they won't demand for it, right? That's what the difference between bandwagon and snob effect is. Okay. So just related with the word snob, the snobbish attitude which people have, that okay, we have an expensive thing which gives them a some sort of a prestige value to it, right? So there was a time when there were just one or two people who owned an iPhone, but now everybody carries it. So probably there will come a time when something more prestigious than iPhone would come into the market, right? So this is what your network or network externalities means. Okay. Okay. Another important concept here is that there is a difference between change in demand and there is a difference in change in quantity demanded. What's the difference? Now, when we say change in quantity demanded, it is only with respect to price, the own price of the good. But when we say that there is change in demand, it is due to factors other than price. Okay. So beginning with your change in quantity demand. In this case, we can have two options. We can have an expansion of demand or we can have a contraction of demand. Okay. Expansion means, as the word suggests, expansion is related to increase in demand. And when will that increase in demand happen? When there is a fall in price. So whenever due to a fall in price, there is an increase in demand, we will say it to be an expansion of demand. On the other hand, whenever due to an increase in price, there is a fall in demand, we say it is a contraction of demand, means your demand is shrinking. Okay. And when we talk about their movement, it is a movement on the demand curve, right? It is a movement on the demand curve. So increase in demand would happen when we move to the right of the demand curve on the x-axis. So whenever we move downwards on the demand curve, it is an example of your expansion of demand. But whenever we move upwards on the demand curve, it is an example of contraction of demand. Okay. Then, what about the change in demand? What about that? In that case, again, we have two options. We have an increase in demand and we have a decrease in demand. Okay, but we all know the basic factor is whenever there is a change in variable that is not mentioned on either the x-axis or the y-axis. This is a general or universal rule that whenever there is a change in variable which is not mentioned on the x-axis or the y-axis, then that would imply any change in variable that would lead to a shift in the curve. And this is what happens in the demand curve. So whenever there is an increase in demand, there will be a rightward shift in the demand curve. And whenever there is a decrease in demand, there will be a leftward shift of the demand curve. Now, for example, if I will ask you this question, okay? If there is an increase in income, so for a normal good, what will happen? Will there be a rightward shift or a leftward shift?
Rightward shift.
Yes. And when there is an inferior good, there will be a
Leftward shifting.
yes. Okay. Similarly, what will happen? What will happen if there is an increase in price of, say, good Y? We have two goods, X and Y. If there is an increase in price of Y, okay, and we are talking about substitute goods, then will there be a rightward shift or a leftward shift?
Rightward shift, ma'am.
Yes. Simply because an increase in price of Y would lead to an increase in quantity of X. And similarly, if it is a complementary good, then in that case, it would be a leftward shift. Right?
Yes.
Okay. Now, while we've talked about some goods, like we've talked about goods that we use for, day-to-day consumptions and so on. But then there are some goods which are durable in nature. For example, we don't change refrigerators every month. We don't change cars every month. We don't change our, washing machines every month. We use them continuously for, say, 10 years or so, right? So whenever a consumption of a good is spread over such a large time span, then we say that those goods are durable goods. Okay. Now, in case of durable goods, their demand is very volatile, right? So if it becomes expensive, if say a durable good becomes expensive, right, its consumption can be postponed. So it's not that urgent, right? If you already have a refrigerator and you want to change it, right, it's not an urgent need that you need it today itself, right? You can still, if there's some problem, you can get it repaired and so on, and then you can postpone the consumption. You will wait when the prices are rational, right? And that is why, because of this, characteristic of postponement of consumption in this durable goods, right? Their demand is very volatile. That's why if you see that whatever schemes are there, whatever sale bonuses, whatever is there, it is mostly in case of durable goods. Such large discounts are there because you never know how your demand would react to it. Simply because they can be stored and their replacement can be deferred. So if your tomatoes get ruined, you will need tomatoes. You cannot just say that, okay, I'll wait for the price of tomatoes to fall and then buy it. No, that is a necessity. But if your AC gets affected or if your AC goes back, your first reaction would be, let's get it repaired. Okay, let's try that out. And then we'll see, right? So their replacement can be deferred, right? and then largely dependent on the expectations of the consumer. So every consumer, if as a person, as a lay person, if I think of buying a car, I would wait for the month of December to buy the same thing, because I know that prices would fall in that month, right? So I'll wait for that. Similarly, if I want to buy a durable good, I'll wait for the Diwali offers there, right? So that is my expectation as a consumer, that I'm expecting that prices would fall during that period of time. Okay. So these are the durable goods here. Another aspect is a derived demand, right? Now, derived demand is that you are not consuming it directly, but that good, that demand is actually helping you produce the good which is consumed directly. For example, labor, right? For labor, we are not consuming labor as such, but we are using the services of the labor who is producing those goods for us. Okay, so derived demand is the demand for goods which are used to produce other goods. Okay. Okay, so we are clear till here. This was just the basics, right? Okay, next is your elasticity of demand. Again, this was given by Marshall, right? And this elasticity of demand measures the responsiveness. This is one of the most important keywords in your elasticity of demand. That how will your demand respond? How will your demand respond to a change in any factor? Right? Now, if you are studying the change in demand due to change in price, it will be called price elasticity of demand. If demand changes due to income, then income elasticity of demand, and so on, right? But as far as if we are using this term, that is just these three words, elasticity of demand, we are not going to assume that it is with respect to price. Okay. Now, so what are the difference? Because before moving forward, like what is the basic difference between your demand and your elasticity of demand? Okay, so demand will only tell you about the qualitative aspect, that you'll only get to know that, okay, with a rise in price, the demand will fall, right? That's what your first thought is on hearing the word demand. But elasticity of demand will tell you that how much will there be a change in demand due to change in price. That's what elasticity of demand tells you. So while demand will only tell you about the trend, but elasticity of demand will tell you actually the quantity by which your demand is affected by a factor. Okay, that is why we say that demand will only give you about the direction of change, but the elasticity will tell you about the extent, to what extent the demand changes. Okay. So what are the different types of elasticities which we have, right? First is your elasticity of substitution. Okay. Now, as I said in the previous lecture, whenever we study about the substitution effect, right, we always talk about your relative prices, right? That is Px upon Py. Okay, so even in case of elasticity of substitution, it will tell you that what will be the proportionate change in your relative demand due to the proportionate change in their relative prices. Now, this proportionate change is mostly reflected by your marginal rate of substitution, right? So marginal rate of substitution is that how much you are willing to give up for one more unit of your consumption. So for example, let's just take this that, okay, are you willing to give up another hour for this session? Right? Though that will reflect you your marginal rate of substitution. Okay. For example, another example, you can say that you have two goods, right? You have, say, a dairy milk and you have, say, a Kit Kat. Okay. So how much of the dairy milk you are willing to sacrifice for one more unit of your Kit Kat will tell you about your marginal rate of substitution. Okay, and this is given, the elasticity of substitution is given by the formula, like you have elasticity of substitution will be equal to the proportionate change in relative quantities. So relative, we are talking about change in quantity of X upon quantity Y. And in case of relative quantities, if we are taking the change, we'll divide the same term with original values, Qx upon Qy. The whole divided by the proportionate change in relative prices, which is given by your marginal rate of substitution. So the proportionate change would be change in MRS upon MRS. So this is what your formula for your elasticity of substitution is. Now, in questions, they can, in your paper, they can actually give you, one possibility is that they can give you direct values of it and you need to substitute in the formula. Okay, so that is one possibility of a question. Another possibility is this table. Okay, so what we can do is, now let's just rationally think it out, not just, cramming this up. We'll just rationally think it out. When there is a perfect substitutes, there are two goods and they're perfect substitutes, absolutely no difference between them, right? So what happens is that price of, say, X increases. Now, because the two goods are perfect substitutes, no difference at all, then the entire consumption will go to your good Y, right? And as a result, the elasticity of substitution is infinity in this case, because the entire consumption shifts to Y. So even if there is a small change, in your price, the consumption of Y increases indefinitely, right? And also, one thing is that you buy X or you buy Y, it makes none of the difference. No difference at all. You consume X or you consume Y. No difference at all for you, right? Then in that case, your marginal rate of substitution will be constant. It won't matter to you that what you consume, how you substitute, or you consume X or you consume Y. Nothing at all. So when MRS is constant, right, then your denominator becomes infinity. How? This will be like equal to, if we just simplify this equation, it will be change in Qx upon Qy divided by change in MRS XY, okay, and multiplied by MRS XY upon Qx upon Qy. So when there is absolutely no change in MRS, because MRS is remaining constant and there is absolutely no change in MRS, then this figure becomes 0. And when denominator is becoming 0, the overall value of ES becomes infinity, right? And then in case of perfect complements, now the marginal rate of substitution is 0, because complements, you just cannot substitute. You have to consume them together. There is absolutely no compromising on the quantity demanded or on the consumption of the two goods, right? If there is a right sock and a left sock, right, you have to consume them together. It is not possible, sorry, right shoe and left shoe. It is not like you wear two left shoes. Not at all possible. There is no marginal rate of substitution, right? So it is 0. So when this numerator becomes 0, the entire value becomes 0. Okay, so this table in itself, it is very important. Okay. Any problem till here? Okay. Now, coming on to the price elasticity of demand, right? So price elasticity of demand is nothing but the proportionate change in demand due to proportionate change in price. Now we are talking about the own price. Now, there have been many a time that this question has been asked, that in which of the following curves, the price elasticity remains constant. Price elasticity remains constant, right? And students have been committing this error, that they will say, just seeing these diagrams, just seeing these diagrams, they will say that in a downward sloping demand curve. That's an absolutely wrong answer. So if you're asked that in which of the following cases the price elasticity of demand remains constant, your answer should be your rectangular hyperbola, right? So in this kind of a curve, the price elasticity of demand is equal to 1 at all points on this rectangular hyperbola. Okay, so this should be your answer. And we always depict price elasticity equal to 1 using a rectangular hyperbola only, nothing else. Okay, but when your change in quantity is much more than the change in price, right? Then we say that even a small change in price increases your quantity demanded considerably. Then we say that you have an elastic demand. And as a result, your elasticity of demand, your demand curve will be flat in nature. So if you just see this, that we have this price, right? Now price increases marginally, say this, right? And demand is here. So this is the change in quantity demanded due to this much change in price. So change in quantity demanded is greater than change in price. So that is why the curve will be flat. Okay. Now, when there is no change, right? When there is no change in quantity, right? Due to change in price, we say that price elasticity is equal to 0 in this case. So what happens is, let's just simplify this formula. It will be change in quantity divided by change in price into price upon quantity. Now, when you see the curve, when you see this curve, the price is changing, but quantity is not changing. So your numerator is 0, right? Then in that case, when numerator is 0, your price elasticity will be equal to 0. And when your price is not changing, but quantity demanded is changing. So when your denominator becomes 0, then your price elasticity will be infinity in this case. Okay. And lastly, we have your price elasticity less than 1, means in this case, if you see that price is this original. Okay, so price fell by this much, but quantity increased by this much only. So the change in quantity is less than the change in price. So in this case, we say that price elasticity is less than 1. Okay. We are good till here?
Yes, ma'am.
Okay. Then, how do we measure your price elasticity? One was this straightforward formula, that is your change in quantity upon quantity divided by change in price upon price, right? So this is one formula. This is the proportionate method, where you divide the proportionate change in quantity divided by proportionate change in price. Now, there's one thing, that a minus sign is always attached to it, right? And this minus sign only depicts the relationship between price and quantity demanded. Okay, so it will only depict whether the goods are like showing a negative relationship, are the goods following the law of demand, or they are the given goods. So whenever you are asked to calculate in a paper, in your exam, if you're asked to calculate, always take this negative sign. Okay, similarly, when you're calculating, for example, let's just say that a price was, say, rupees 5, and quantity demanded at that price was 10, right? Price increased to, say, 10, and quantity demanded fell to, say, 6. Okay, now here change in prices, P2 minus P1, which is equal to 10 minus 5, 5. And change in quantity is Q2 minus Q1, that is your 6 minus 10, which is equal to minus 4. Okay, so change in quantity upon quantity divided by change in price upon price, right? A minus sign here. So minus, it will be change in quantity is minus 4 divided by your original quantity is 10. So 10 divided by change in price is 5, and your original price was 5. This is this. So your answer would be 2 by 5, that is your minus minus gets cancelled. It will be 0.4. This is your elasticity. And when elasticity is less than 1, then in that case, we say it is an inelastic demand. Because if you just randomly see this, your change in price is greater than the change in quantity. So definitely it should strike to you that it is an inelastic demand. Okay, so this is your proportionate method. Now, next method is your point elasticity method. Now, why I said that your elasticity changes along a demand curve, a downward sloping linear demand curve, was because of this method. Now, this method says that price elasticity is equal to your lower segment and upon your upper segment. Okay, your lower segment upon your upper segment. So if we take the midpoint, say this. Now at this midpoint, your lower segment is equal to your upper segment. So this ratio becomes equal to 1. That is why at the midpoint, your price elasticity equals to 1. Now, if we take this point on the x-axis, here lower segment is 0. Upper segment is complete. So when the numerator is 0, then in that case, your price elasticity will be equal to 0 here. And when we take the point on the y-axis, your lower segment is there, but upper segment is 0. So when the denominator is 0, then in that case, your price elasticity is equal to infinity. And in between these 2 points, right, your price elasticity is between 0 and 1. That is your inelastic demand in the lower segment, in this, and in this region, your price elasticity would be between 1 and infinity. That is your elastic demand. Okay. Then what we've been doing is till now, like if you are finding it on the demand curve, we are finding the elasticity of demand on one particular point, and so on, right? So that is like we're just taking one point into account. We are changing quantity from 1 to 1. That's it. Nothing else, right? So at this point, the price elasticity of demand is this. At this point, it is this, right? So we are just considering that, right? But what happens when we have to find the price elasticity of demand from, for example, point A to B? We have to find the price elasticity of demand over this entire range, right? So in that case, we use the method of arc elasticity. And arc elasticity is used when the price or quantity change is large, right? So we are not just taking two simple points. We are not just taking point A, point B. No, we are taking into account this entire range. And that's why we use arc elasticity method, right? Which is also known as your midpoint method. So arc elasticity will be nothing but Q2 minus Q1 divided by Q1 plus Q2. Usually some books also divide this by 2, right? But it just 2 and 2 gets cancelled, so it doesn't make a difference, right? So this is, so usually I avoid that, like, because in any case, the numerator and denominator would cancel each other out. So that's okay, right? Then divided by, okay, P2 minus P1 upon P1 plus P2. This is what your arc elasticity method is. Okay. And then we have your revenue method. We'll use this a lot in your production theories. So keep a note of it, right? And this is like revenue method tells you that how much a change in price would affect your revenue. This is mostly for the firms. This is used by firms, not the consumers, but the firms. Okay, so how will a change in price affect the revenue earning capacity of the firm is studied under your revenue method given by AR upon AR minus MR, right? Okay. Now, last we have is your total expenditure method, right? This was again given by Marshall. This was again given by Marshall, and it tells you that how your expenditure changes, right? For example, like an increase in price of a commodity, okay, does not, like so let's just say the example of medicines, okay? We take this example of a medicine, okay? Now, if okay, diabetic medicines, right? Diabetes, right? They have to take that medicine, right? They have to take the insulin shots. Now, if the price of insulin shots increases, right? So their quantity won't change. They have to take it. It won't be like they will stop taking it because of the increase in price. And what happens in that case is their expenditure increases, right? So when price movement and expenditure movement go in the same direction, we say that it is an inelastic demand, right? But if a price increase leads to a fall in expenditure, a fall in expenses, that will say it will be an elastic demand, right? So there's a time during like summer seasons and everything, there's a time, there's a peak time, right? You don't go in for, like electricity consumption, you take a note of it, right? It's not like you're not, okay, that's a bad example. Electricity is a necessity good. So, okay. So, yeah, when you're planning a holiday, right, there are people, the budget travelers make sure that they don't go in the peak season, right? Simply because the expenses would be very high during that time. So they will not travel during the peak season in a place. So what happens during the peak season, the prices increase, right? So they would withhold their travel plans, and as a result, their expenditure decreases. That implies that it is an elastic demand. Okay. But there are cases when an increase in price keeps the expenditure constant, keeps the expenditure constant. It does not change. Then in that case, your demand would be unitary elastic, right? So increase in price, you are decreasing the quantity in a similar way. It's okay, right? It is not the example of necessities, but you can say it's some luxurious goods. Like, for example, you can take the example of, say, chips, which are not really needed, but then your consumption would fall. If the price of chips increases, your consumption would fall accordingly, right? Which keeps your expenditure constant. Then in that case, it is a unitary elastic product. Okay. And then we have is your case of, these were the examples of your price elasticity of demand. Okay. Then you have the case of income elasticity of demand. Income elasticity in the sense that change in quantity due to change in income. Okay. Now, income in the case of income, we have a normal good and we have an inferior good. Normal good, that increase in income would lead to increase in quantity demanded. Inferior goods, an increase in income would lead to a fall in quantity demanded. Similarly, when there is this positive relationship that is identified between your income and quantity demanded, then in that case, your elasticity of demand, the income elasticity of demand will be greater than zero. That is verified. Okay. And in case of inferior goods, when there is an opposite movement between income and quantity demanded, then in that case, your elasticity of income would be negative. That is, it will be less than zero. Okay. But in case of normal goods, we have two types. That is necessities, we have luxuries. Necessities are that you will consume it, right? So if your income increases, it's not like you will start having 6 meals a day. You usually have 3 meals, breakfast, lunch, dinner, and you'll continue having that. Probably you'll increase roti, you'll increase the number of dishes, but it will not be to such an extent that, that brings a drastic change in your expenditure levels, right? So there are necessities that, okay, positive impact, we might have an additional meal of a snack time probably in the evening, but it won't be to a large extent. So in the case of necessities, your income elasticity remains between 0 and 1, right? But in case of luxuries, now necessities are goods that are not like a major proportion of your budget is not spent on necessities. You don't spend lakhs on salt. You don't spend lakhs on, flour or rice, nothing like that. Right? They are very small proportion of your total income. Okay. But then the major proportion of income is spent on luxuries, right? So if luxuries, in case of luxuries, you may be spending lakhs of your rupees on, say, a nice luxurious car. You may buy a new AC, you may buy a new television, new phone, and so on. So for them, that elasticity of income is income elasticity of demand is greater than 1. Now, this one is very important. It will segregate the goods into luxuries and necessities. Okay. Zero, it will, if the term zero will segregate the goods between your normal goods and inferior goods. So this 0 and 1 plays a very important role, right, in measuring or in interpreting the income elasticity of demand, right? As far as the graphical presentation is concerned, the angel curve, it represents, it reflects the relationship between income and quantity demanded, right? So income being on the y-axis and quantity demanded on the x-axis. So necessities are those goods that you need to consume, that you will be consuming, right? So a large change in income, say this much, will bring about a less than this change in your quantity, right? So if you see that income change is greater than the quantity change. And when that is the case, it is a case of necessities. But when there is an income change, which is income change here is less than the quantity demanded or is less than the change in quantity, right? Then in that case, it is a luxury. Okay. And when we have a negative sloping curve, means a rise in income is decreasing the quantity, then in that case, it is a case of inferior good. Okay. And lastly, we have the case of cross price elasticity of demand. That is, how will the demand change due to prices of related goods? Okay, so how will your demand respond due to change in price of a related good? That's what is measured by your cross price elasticity of demand, which is given by change in quantity demanded of X due to change in price of good Y multiplied by Py upon Qx. Okay, Qx, sorry. Right? Now, as we said that if there is an increase in price of Y, there will be an increase in quantity of X. When there is a positive relationship that is determined, it is a case of substitute goods. But when an increase in price of Y leads to a fall in quantity of X, that is a negative relationship between them, it is a case of complementary goods. And lastly, when your EC is equal to 0, that is, a change in price of Y does not affect the change in quantity of X, that means the goods are unrelated. Okay? Right? So I'll stop here, right? And then we'll start off with your theory of consumer demand in tomorrow's lecture. Everything's fine till now?
Yes, ma'am.
Okay. Any problem, anything